Welcome to my KTM video playlist. Today we are going to see types of flat belt drives. Let's see first of all the outlines of the session. First we will see open belt drive, then cross belt drive, next compound belt drive. So these are actually the types of belt drive. Quarter turn belt drive, next belt drive with idle pulley, or sometimes it is called as idler pulley, step or con pulley drive, and at last we will see fast and loose pulley drive. We will see briefly all types of the flat belt drives one by one. So let's see first of all the classification of the belt drive, or simply we can say types of arrangement of the belt drive. So first one is open belt drive, then cross belt drive, then compound belt drive, then quarter turn belt drive, then belt drive with idle pulley, then step or con pulley drive, and at last fast and loose pulley drive. So these are the different types of the belt drives, or we can say different types of the arrangement of the belt drives. Now let's see first one. What is belt drive? So here you can see this is the driving shaft. That means you can provide the input over here, and so that you can transmit the power from driving shaft to the driven shaft with the help of the belt drive. In this figure you can see the driving shaft is rotating in anti-clockwise direction, and so the driven shaft also. So both having the same direction. In this figure you can see this is the driving shaft which is rotating in the clockwise direction, and so that the driven shaft will also rotate in the clockwise direction. So simply you can transmit the power by using the belt drive in the clockwise direction or in the anti-clockwise direction. The belt is flexible element of a belt drive system. Here you can see it is a flexible. It is used to transfer the power from one shaft to the another shaft. This is a very simple introduction of the belt drive. Now let's see the classification one by one. First one, open belt drive. With the help of these three different figures, we are going to understand the open belt drive. In the open belt drive, the shaft rotates in the same direction. That means the direction of the rotation is the same as the driving and driven pulley. Here you can see the driving shaft is rotating in anti-clockwise direction, and so that for the driven shaft. That means both having the same direction. Here both are rotating in the anti-clockwise direction. Next, the shafts are arranged in the parallel direction. Here you can see both the shafts are parallel to each other. Here also you can see these all are called as the open belt drive arrangement. So here both the shafts are parallel to each other. If the shafts are having a more distance between driver and driven, then one side will be slack side and the other side will be tight side. Here you can see if the distance is more between two shafts, then one side of the belt is tight side and another one is the slack side. Here you can see in this figure, this is the slack side and this one is the tight side, because of this is the input. So from the input side, the belt will be in tension over here compared to this side. So this will be tight side and this one will be slack side. Next, the driving pulley pulls the belt from one side, here you can see, and delivers it to the other side. Thus, the tension in the belt CD will be more than the belt in the EF portion. And that's why it is the tight side tension and it is called as the slack side tension. So tight side tension is always higher than slack side tension. The belt CD, because of more tension, is known as tight side, whereas the belt EF, because of less tension compared to this one, is known as slack side. Next one, cross belt drive. Here the belt is cross, and that's why it is known as cross belt drive. Sometimes it is called as the twist belt drive because of it is twisted over here. And this is the practical application of the cross belt drive. In the cross belt drive, the transmitted power is more due to more contact angle. Here you can see the belt is contact to the pulley from here to here. That means the contact angle, here you can see, that is more compared to the open belt drive. That means the previous one. So if you increase the contact angle, so definitely you can increase the power transmitted capacity. But it cannot run faster because of it is twisted over here. If so, then rubbing between the belts may wear and tear. Here you can see the belt contacted over here, and if you increase the speed, then there will be the rubbing between belts, and so that there will be wear and tear. In this, the shaft rotates in the opposite direction. Here you can see this is the driving shaft. It is rotated in the clockwise direction, whereas in case of the driven shaft, it is rotating in anti-clockwise direction. So this is the main difference between open belt drive and cross belt drive. For the open belt drive, both are rotating in the same direction, whereas in case of cross belt drive, both are rotating in opposite direction. Next one, compound belt drive. In this drive, a particular shaft holds two or more pulleys as shown in figure. Here you can see this particular shaft having two pulleys. Here you can see B and this one is the C pulley. In this figure also you can see this shaft having two pulleys, pulley 2 and pulley 3. So very simple, in case of compound belt drive, a particular shaft having two or more pulleys, then it is called as compound belt drive. When it is desired to increase or decrease significant speed, the compound belt drive assembly is considered to be the most effective method, and it eliminates slip. Here you can see if you transmit directly the power from this to this pulley, then there will be less contact angle. But if you provide this type of the compound belt drive arrangement, then you can increase the contact angle, and so that you can reduce the slip. In this combination, pulley B and C, here you can see, are the compound pulleys. That means pulley C is keyed on the same shaft on which pulley B is mounted. So both the pulleys are mounted on the same shaft with the keys. That means both having the same RPM. The speed of pulley B, that means the RPM of the pulley B, and RPM of the pulley C, that means NB and NC is always same. So here it is written NB, that means the speed of the pulley B, and NC, that means speed of the pulley C. In this figure you can see N2 is equal to N3 because of both these pulleys are on the same shaft. Next one, quarter turn belt drive. Sometimes it is called as right angle belt drive. So here you can see this is the model of the quarter turn belt drive, so that exactly you can understand. This is the simple figure that you can draw in the examination for the quarter turn belt drive. Now let's see briefly. The quarter turn belt drive, also known as right angle belt drive, because of both the shafts are actually at right angle to each other. Here you can see these both are not parallel to each other. It is used with shafts arranged at right angles and rotating in the definite direction. Here you can see rotating in the definite direction, that means as per our desire. Now next one, belt drive with idle pulleys. Sometimes it is called as jockey pulleys. So in this figure you can see first one is called as the open belt drive, but if you provide the idle pulley, then it is called as the belt drive with idle pulleys. Here you can see this is called as the idler pulley also, and with the help of the idler pulley you can increase the contact angle. Here you can see it is called as the rape angle also. So without idler pulley the rape angle is less, but by using the idler pulley you can increase the rape angle. That is the important point for this type of the arrangement. So here this pulley is known as the jockey pulley also. So jockey pulley is an idler pulley which is used for increasing the angle of contact. Here you can see to reduce the slip in an open belt drive. So in the open belt drive you can use the idler pulley so that you can reduce the slip. You can increase power transmission capacity also by using the idler pulley. This is the practical application of the idler pulley so that you can increase the contact angle over here. This is actually the timing belt, but simply you can understand by using the idler pulley you can increase the contact angle. Next one, step or cone pulley drive. Here you can see the figure. The pulleys are like as a cone, that's why it is called as the cone pulley drive. Or you can see the pulleys dimension are actually reduced in the sequence so that it is called as step pulley drive. Here more pulleys of different diameters are attached adjacent to another. Here you can see there is a one shaft but on which there are more pulleys having different diameters. In this figure also you can see having different diameters. It is like this, and this is the animation. Here you can see having different diameter pulleys are attached. Step or cone pulleys are used where they have to change speed of driven shaft frequently like a machine. In workshop you can see lathe machine, milling machine and many more, where you have to change the speed of the driven shaft frequently. So at that time this type of the arrangement is generally used. The shafts are placed parallel to each other. Here you can see both the shafts are parallel to each other and they are so aligned that the largest pulley, in this figure also you can see, the largest pulley of A falls just opposite to the smallest pulley of the B. The diameter of all steps of A and B are so adjusted that the same belt can be used. From this figure you can understand this is the smallest pulley and this one is the largest pulley. So you can change the huge amount of the speed. So this is the very simple figure. Here you can see the cone pulley, or you can say the step pulley. So this is the practical application of the step or cone pulley in the lathe machine. Now the last one, fast and loose pulley drive. In this figure you can see these both are the shaft, where this one is the driving shaft and this one is the driven shaft. So on the driver shaft there is a single pulley, but on the driven shaft there are two different pulleys. One is called as the fast pulley and second one is called as the loose pulley. Fast pulley is mounted on this shaft with the key, whereas loose pulley is mounted on the shaft with the help of the bearing. That's why it is called as the loose pulley. This is a very simple figure which you can draw in the examination for the fast and loose pulley drive. So very simple. On the driving shaft there is a single pulley that is called as the driving pulley, but on the driven shaft that is called as the machine shaft also, on which there are two pulleys. One is called as a fast pulley and second one is called as the loose pulley. Keep in mind, fast pulley is mounted on the shaft with the help of the key, whereas loose pulley is mounted on the shaft with the help of the bearing. As the name indicates, there are two pulleys, fast and loose pulley. Here you can see fast and loose pulley on the driven shaft. The fast pulley is mounted on a shaft with keyed joint and the loose pulley runs freely on the shaft and it is incapable of transmitting any power. When multiple machines are working from a single power source, that means the line shaft, this is called as the line shaft and this is called as the machine shaft. So this is a single input source and with the help of that you can run many of the machine. That's why it is called as the machine shaft. Then it is required to stop or run one machine frequently without stopping the line shaft. So in this situation, each machine has provided with this type of the fast and loose pulley. So if you want to run the machine shaft, then you can arrange this belt with the fast pulley so that machine shaft will rotate. If you want to stop this machine shaft, then you can mesh the belt with the loose pulley so that the machine shaft can stop. Thanks my dear friends for watching this video. Press the like button to appreciate.